Hello, all of you guys. A warm welcome to all of you. Today I'm going to discuss the beta functions and the consequences and facts related with beta functions, and I'm going to show you that we have introduced the gamma functions previously. So, what is the relationship between gamma and beta function? Okay. Beta functions are a special type of function which is known as Euler integral of the first kind. Okay, so beta functions setup or the definition of beta function or how mathematically beta functions is written as follows: that beta L comma m equals to integral 0 to up to 1 x to the power L minus 1 times 1 minus x to the power m minus 1 dx. Okay, so this is the typical setup or the mathematically we define beta functions. So as I am saying that beta functions is a special type of function which is known as Euler's first integral. Okay, so which is known as Euler's first kind of integral. So it is usually expressed as this format, this beta. So beta L comma m, this format it is always expressed, and so it is basically follows a symmetric property. Symmetric means if you say that beta L comma m equals to beta m comma L, so this is called the symmetric property. Symmetric property of beta functions. So basically functions actually play a very important role in mathematics, and it is defined as a spatial association, not and use spatial. So it is basically the association between the set of input and output values in which input values correlates one single output value. Okay, so we know that there are two types of Euler integral functions. One is a beta functions and another one is gamma functions. Okay, so I'll say that the functions, so here I'll write that functions defined as association between the set of input and output values, in which each input value correlates one single output values. So this is the main concept or the idea of defining a function. Okay, so you see the domain range or codomain of functions depends on its type. Okay, so as I am trying to make you understand that what beta functions do. Okay, so beta functions, so let us first see the symmetric property. So as you see this beta function, so we can prove this symmetric property from the definition of beta function. So as beta L comma m is equals to 0 to 1 x to the power L minus 1 minus x raised to m minus 1 dx. Okay, so you know as okay, so we can write this 0 to 1 minus x to the power L minus 1, and this is 1 minus x raised to the power m minus 1 dx. From where we can define this? We can define this from the idea that integral of 0 to a f of fx dx equals to 0 to a f of a minus x dx. We know this. Okay, so from that point of view I am writing this entire thing. Okay, this is the justifications. Now I will write that 0 to 1, that is 1 minus x. Okay, yes, so if you just calculate this part, okay, so x will left with, so we left with x, so that's why this x comes to first m minus 1 and 1 minus x to the power L minus 1. So we can write beta m comma L, and we have proved beta function is follow symmetric property. That means it doesn't matter whether this m come first or L come first, both are same thing. Okay, so the beta functions is a definition is or if you ask them what is the motivations or main um, insights, what insights we can receive to study the beta function. So beta function explain, so I'll write beta function explains the association between the set of inputs and the outputs. Each input value the beta function is strongly associated with one output value. Okay, so this is the main motive, or this is what beta functions do in context of um, problem solving or any other field of mathematical applications. Okay, so now we'll go to evaluate the beta functions. I mean, the what is the this value approaches as we did for gamma functions. So we'll do that. Okay, so let me place this thing properly. Great. Fine. So we'll now go to evaluate the beta function. So we have, so we have beta L comma m equals to 0 to 1 x to the power L minus 1 minus x m minus 1 dx. Okay, so m be a positive integer, so then we'll solve this doing by parts, integration by parts, and this 1 minus x term, this 1 minus x will be our first function. Okay, so this is equal to, so as it is our first function, so we will write 1 minus x to the power m minus 1 times, so we'll do the integration of x to the power L minus 1, so it will be x to the power L over L. So limit 0 to up to 1. So this is, so now 0 to 1 x minus 1. Our next motive is to derivative of this 1 minus the left of this portion, that is our first function, and we will do so, and we will get 1 minus x to the power m minus 2 x to the power L, again the integration. So this is okay, and we will get m minus 1 L integration 0 to 1, okay, 1 minus x m minus 2 x to the power L dx. Okay, fine. So let me cut these things. Okay, now again beta L comma m can be represented as m minus 1 times m minus 2 over L times L plus 1, and if we do so, you'll see 0 to 1 1 minus x to the power L minus 3, sorry, this is m minus 3 x to the power L plus 1 dx. Okay, so again I will cut these things and place these things here. Okay, so now great. Now applying this process with again and again and again, so if we apply this process, so applying this process several times, we'll see that beta L comma m is equals to m minus m 1, sorry, m minus 1 times m minus 2, and it will up to like this 2 times 1. Okay, and in denominator L times L plus 1 times, so it will continue up to L plus m minus 2. Okay, and we will left with the one integral, that is 0 to 1 x to the power L plus m minus 2 dx. So you see, we always left with such integral. Okay, this 1 minus x term, it will somewhere down the line, it will it will vanishing out. Okay, and we'll always left with some not I won't say this will vanishing out. Actually what will happen, Yeah, actually this 1 minus x things will like vanishing out, or it will something like the compressing out, and we'll left with something x to the power l mi- l plus m minus 2. That is, whenever you will do this time, so I have I have done this for 2 times. So if you do this 3 4 5 times, you will see, you will always whenever you will perform this beta things, you in denominator things l times l plus 1 times it will be l plus 2, I guess, and then you will approach, and whenever in denominator time this will comes again, these things will be in x to the power l plus 1 is, you are seeing this here. Again, whenever third times you will do so, so you see that again in denominator l plus 2 will remain, and in x will be something x to the power l plus 2. Okay, so I'm sorry, uh sorry so whenever you will we do so. Okay, so all right, so in denominator case, okay, so l, so for x it will be x to the power l will left, for l plus 1 it will left with, it will left with x to the power l plus 1, for x l plus 2 it will left with x to the power l plus 2, and so on. Okay, now you see, so this is m minus 1. So how many times, how many uh, it is going on? So that's why we are writing this like if we keep continue this, so that's why we will left with l plus m minus 2. Okay, well, so if we do so, the numerator will turns into m minus 1 factorial. Okay, and you see this will left with l times l plus 1, and times l, so l plus m minus 1. Well, wait, so it will l plus m minus 2 times l plus m minus 1. So how I am doing this? So if we again integrate this, we'll get l plus m minus 1 things, and it will goes into turns into 1, or we are actually not happening, so not exact. I'm not saying that this will be exact, it is something like uh, it will compressing out, I mean, you see, so it will decaying or something like that. You can intuitively say that it will go like this. So if we again integrate this, so if I do the integration of integral of 0 to 1 x to the power l plus m minus 2. Okay, so it dx, so you see l plus m minus 2 plus 1, and this is x to the power l plus m minus 2 plus 1, and this will be 0 1. Okay, so we'll left with l plus m minus 1 here, and or 1, and this is x to the power l plus 1, not l, plus m minus 1. So if we put the limit 0 to 1, so now you see that what will happen here, and that's why we are writing this m minus 1 factorial here, and here we left with l plus m minus 1. So actually how these things coming up, so this entire thing, this l minus m minus 2, so if you keep continuing this process numerous number times, this 1 minus x factor will vanish, and we'll left with this x terms, and if we do so, integral will left with this part. Okay, so this is what happening actually. Okay, so this is a bit tricky part of this evaluation of beta functions. Okay, so again I am saying that if you do so, if you continue the process of this doing this integration, so l plus 1 and so many things will coming up, and this 1 minus x terms will vanishing up, and you will left with these terms with x raised to the power l plus m minus 2. So that is the thing. So why m things is coming up here, it can be the question. So the thing is, if you keep following a pattern like this, okay, so by following a pattern, by seeing this pattern, or to keep balance in the pattern, this we are providing such things. Actually I'm not able to express what to make you understand, but still if you have some doubts, if you have some any question you want to raise, so please ask in the chat box. I'll try my best to answer it, or work on this, because such questions, if such question will come up, and you come up such questions which can be needs to be answered, so I can work on this. Okay, so actually to make someone understand that how these things popped up, so it is quite a difficult, but I mean, I won't say that difficult, but it is a bit tricky, and you have to understand by doing this 2 or 3 4 for at least 7 or 8 or 10 times. If you perform this process, you will understand that how these things actually, when I learned these things, I have performed this 8 times. Okay, so if you perform this integral at least 10 times, and you will see that how this 1 minus x terms is going to when I mean, it's this 1 minus x going to like something, as the power will from m, so from m to these things will I mean this here is something. Okay, so here is something, so it will going to increase as it will going to increase. So this factor will increase, and this m is going to I mean from m it's going to eliminate, and as these things is going to eliminate, so 1 minus x will left with this. So it means what? It means 1. Okay, that's basically happening here. Okay, and we'll perform this, and we'll left with these things. So this is a intuitive, not so you can write a program or something like that, so you can understand how this things is going on. Or so I appreciate if you write some programs, or if you do some simulations to understand this. Okay, so actually I performed this 10 times when I first learned this beta function. So to understand the process, that what is basically going on, why this factor is coming on, this factor, and how these things, and where this 1 minus x terms uh, is there, or where is uh, 1 minus x, how this 1 minus x term is going to vanish. So that is quite intuitive, and you should understand this, uh, the basically the insight behind this beta function. So only as so let we'll claim that let only L be a positive integer, then and since beta L comma m equals to beta m comma L, so beta L comma m nothing but L minus 1 factorial over m times n plus 1. Okay, so up to m plus L minus 1. So if you just perform the so L and m, if you just change, make some changes, or perform a bit, I mean this, if you follow the symmetrical property of this beta function, so you can write these things as well. Okay, so as you can write these things, so L and m both positive integer, so you can write that beta L comma m, well, L comma m can be written in this form as well, m minus 1 factorial. Okay, and this L times L plus 1, uh, you keep continue this, it will also, so L plus m minus 1, and beta lm L comma m is m minus 1, m minus 2, again L minus 2, and this is up to 2 times 1 over 1 times 2. I'm sorry, this is 1 times 2 times dot up to L minus 1 L times L plus 1, and if you carry on this, you left with L plus M plus 1. Now if you multiply the numerator and denominator, okay, with this, like multiplying the numerator and denominator by 1 times 2 dot 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 up to L minus 1, so you will left with beta L comma M equals to M minus 1 factorial and L minus 1 factorial. This is L minus M minus 1 factorial. So that's how the beta L comma M 0 to 1 x to the power L minus 1 minus x to the power M minus 1 dx is evaluated, and we get this M minus 1 factorial N minus 1 and L minus M minus 1. So this is the entire setup of beta function. Okay, so I'll suggest that to work on these beta functions, those who are watching this video, please do follow the mathematical work, and if you keep follow this or try to perform, if you have some books where these things has derived better than me, better than I derived here, so you can definitely consult that book. Even if you can suggest me better approach or better way to do so, please do let me know that how could I approach better, or how easily this can be solved, because actually I have learned these things in my undergrad times. If you know a better approach, you can definitely suggest, or if here as much I can see, as much as I can see that there is no fault, if you see here I am making something wrong or fault, you can definitely let me know in chat box, I mean the comment section. So or if you are trying to understand this entire operations I have performed here, you are most welcome. Try to understand, work these things, work on these things, and you can suggest me a better approach to do so. If you have any contents, any book or any lecture notes where it is performed in a better way, so you can definitely suggest me. So actually I don't go further more today, because you need to digest these things, I believe that. And in the next session I will discuss the relationship between beta and gamma functions, and how we and we'll do some problems based on beta functions and gamma function as well, how beta functions gamma functions relations helps us to solve numerous problems. We'll definitely do so in our next session. So for this time being, thank you, study hard, and take care of yourself. Thank you, bye bye.